Welcome to Cool Guy Podcast. Is there life on Mars?
Well, a pretty extraordinary claim
A huge one.
that NASA's Perseverance rover may have found the clearest sign of life we've ever found on Mars. That's a massive statement.
It is. And Percy, the rover, its whole mission is basically to hunt for signs of ancient microbial life. It's in the Jezero crater for a reason.
Which was an ancient lake bed, right? So perfect spot.
Exactly. Rich in the kind of clay minerals where you'd expect life to, leave a trace.
And this trace is, well, it's incredibly small. We're talking about these tiny spots in mudstone.
So small. Nicknamed leopard spots and poppy seeds. Some are only about 200 micrometers wide.
So what's so special about these little spots? What's in the rock?
Okay, so the rock sample itself, it's called Sapphire Canyon, has the right starting recipe. It's rich in organic compounds.
Like carbon, phosphorus.
Right, and iron. But the real smoking gun, or potential smoking gun, is the chemical evidence. Percy found vivianite and iron phosphate and also greigite.
And if we look at that through an Earth-based lens, that combination is very suggestive.
That's the critical point. Here on Earth, if you find dark spots rich in iron and phosphorus with those specific minerals, it's almost always linked to microbial life.
Like specific kinds of microbes.
Yeah, think of something like Geobacter. It's a microbe that essentially breathes iron to get energy. It's called chemosynthesis. And the combination of organics, water, and that iron reduction it checks all the boxes.
But you have to be skeptical. The research team, their first job is to try and prove it's not life, right?
Oh, absolutely. That's the core of it, the scientific method of falsification. They spent months trying to find a non-biological explanation.
So what did they rule out? How can they be so sure from millions of miles away?
Well, the on-site chemistry is pretty powerful. First, they ruled out high temperatures, like from a volcano or an impact.
Why?
Because vivianite, that key mineral, it only forms at low temperatures. Intense heat would have just destroyed it.
Okay, that makes sense.
Then they ruled out reactions with acidic water. And this is really clever. Percy found another mineral nearby called olivine. And olivine, well, it gets destroyed by acid very, very quickly. So if the water had been acidic enough to create these spots chemically, the olivine just wouldn't be there.
So after all that, they just couldn't find a non-living process that fit the evidence.
That's the conclusion. Ancient microbial life is, for now, the best explanation for the pattern they see.
It sounds so promising, but we have been here before, haven't we? I keep thinking of past false alarms.
We have, and we have to be cautious. You think back to the Viking lander in 76, or that meteorite, ALH 8400 in the 90s with the little squiggles in it.
Both of which were eventually explained by non-biological processes.
Exactly. Which is why this time we need to get that sample back here. Physical proof is everything.
And that brings us to the Mars Sample Return Mission, this hugely ambitious, wildly expensive project.
Over $11 billion. But the scientific community, the Decadal Survey, they designated the highest priority for a reason. We need that Sapphire Canyon sample in a lab on Earth.
Because there are tests you just can't do with a rover.
2 smoking gun tests, really. The first is chirality.
Checking if the amino acids are all left-handed or right-handed.
Precisely. Life on Earth shows a strong preference for left-handed ones. A random chemical process would have a 50-50 mix. The second is carbon isotopes.
The ratio of carbon-12 to carbon-13?
Yep. Living things prefer the lighter carbon-12, so you get a very distinct ratio compared to non-living matter.
So right now, where does this discovery sit on, say, NASA's official scale?
I'd say it's likely a level 3 or 4 on the confidence of life detection scale. It's suggestive, very compelling, but not a confirmation. Getting that sample back could push it to a level 6 confirmed life.
Wow. And what strikes me is that studying Mars is almost like studying ourselves.
It is. It's like looking into a time capsule of an early Earth. Our planet's ancient crust has been recycled by continental drift and worn down by erosion.
But Mars is frozen in time.
Exactly. So understanding Mars helps us understand our own origins.
That's a profound thought. But let's just, for a moment, take that final leap. What if it is life? It makes you think of what some call the 0-1 infinity rule, the idea that if life only happened once, here it could just be a fluke.
A one-off.
But if it arose independently in 2 places, here and on Mars, then the probability that it's everywhere, it just skyrockets. If it's 2, why not infinity?
The stakes couldn't be higher.
It's literally the answer to the question, are we alone in the universe?